Okay, listen. The first question. Okay. What is the first question, dear students? Ethers preparation methods. We know very well. The well-known ether preparation method is Williamson ether synthesis. The first one is Williamson's ether synthesis. Okay, see in the Williamson ether synthesis, alkyl halides reacts with sodium alkoxides. This is sodium alkoxide. It is a nucleophile. Here in this reaction, it is a nucleophile. Produce ROR dash. Okay, and what is R? R means this R is equals to should be primary alkyl group. Primary alkyl group. Okay, and X is equal to chlorine, bromine, iodine. Chlorine, bromine, and iodine. Then R dash may be, what are the possible? R dash may be primary, secondary, and tertiary alkyl groups. Tertiary alkyl group. Okay, so based on that, corresponding products will get. Okay, let's see that which is not possible. Which is not possible means the first one, bromoethane C2H5Br reacts with sodium ethoxide NaO C2H5. The product is C2H5 bond O C2H5 diethyl ether. Okay, now it is okay. First one is possible for the synthesis of ether. Let's see the second one. The second one is C2H5Br reacts with sodium ethoxide. See, if you observe this R group is alkyl groups only present, but here it is also primary alkyl and it is also primary methyl. Methyl group is present and corresponding ether is C2H5 bond O bond CH3. And third one is methyl bromide CH3Br means alkyl halide reacts with sodium alkoxide, sodium ethoxide, and produce corresponding ether CH3O bond C2H5. But the fourth one is C2H5Br. Okay, one is alkyl bromide reacts with sodium formate. The sodium formate is not sodium alkoxide. Okay, cannot form ether. Okay, students. So, which reagents cannot form ethers, dear students? Fourth option. Because the remaining 1, 2, 3 are, one is alkyl halide, the second one is sodium alkoxide. Sodium alkoxide. See, I gave in the above first general equation I gave that alkyl halide must should be primary alkyl halide reacts with primary sodium alkoxide or secondary sodium alkoxide or tertiary alkoxide, tertiary sodium alkoxides, then produce corresponding ethers. Corresponding ethers is known as a Williamson ether synthesis. It is very, very important, those conditions. So based on that, further applications also came so many. It's very, very important. You have to remember these conditions. What is this R group and what are the possible R dash groups? Must very, very important. Okay. Let's see the next question. The second one, what is Y in the following reactions? What is Y they are asked? Let's see the second one. First one is the formation of X is according to Williamson ether synthesis. CH3 bond CH2 bond I. Okay, reacts with sodium ethoxide Na plus O C2H5. Sodium ethoxide this reaction is takes place according to SN2 mechanism. And one more important point, dear students, Williamson ether synthesis is taking place according to SN1 mechanism only. CH3 bond, CH2 bond, O, CH2, CH3, diethyl ether is the product. This is X. Okay, this X, the byproduct is sodium iodide. This X is treated with 2 moles of HI, hydrogen iodide, means the cleavage of ethers. Cleavage in presence of HI, cleavage of CO bond. CO bond C. This bond will be cleavage and produce. This will be cleavage and produce corresponding C2. Sorry. CH3 bond CH2 bond I, 2 moles of ethyl iodide plus water will forms. Okay, what is Y, dear students? The Y is ethyl iodide. So the answer is second option. Okay, let's see the third question. Which of the following cannot be prepared by using Williamson ether synthesis? Here, the first one. Here, benzyl paranitrophenyl, PHENYL, this Y, phenyl ether. The first one is methoxybenzene. Methoxybenzene means it is the product formula directly I will write. So regarding this, what are the suitable reactants we need to choose? Okay, methoxybenzene is nothing but anisole. This anisole do you want to synthesize according to Williamson ether synthesis means this should be the alkyl group should be alkyl group. It should be alkyl group, alkyl halide. Then sodium phenoxide, because the halogen is directly attached to the benzene ring. If they cannot undergo nucleophilic substitution reactions. We know that aryl halides are less reactive in nucleophilic substitution reactions. That's why it is CH3I plus Na plus O minus C6H5. Then we will get methoxybenzene. Otherwise, if you are arranged this structure like this, the reaction is going like this. Halobenzene, either chlorobenzene or bromobenzene. Okay, it reacts with CH3O Na, sodium methoxide, then no reaction, because aryl halides does not undergo. This is halogen is attached carbon is sp2 carbon. They cannot undergo SN2 mechanism or cannot undergo nucleophilic substitution reactions. That's why, okay, anisole or methoxybenzene is possible by the reaction between methyl chloride or methyl halide and sodium phenoxide and produce anisole. Now the second option, let's see. The second option is benzyl paranitrophenyl ether. Benzyl paranitrophenyl ether. Benzyl group C6H5CH2O paranitrophenyl ether. This is the product. This product is possible when the Williamson ether synthesis is reaction between benzyl chloride plus sodium phenoxide. C6H5H4 bond NO2 paranitro sodium phenoxide, then produce this corresponding product. Now the third one, let's see, the third one is methyl tertiary butyl ether. Methyl means the methyl group should be methyl chloride or methyl halides and Na plus O. See, this is tertiary, sodium tertiary butoxide. Already I said in the first question only, general equation, the R dash group should be primary, secondary and tertiary. So this is a tertiary alkyl group. That's why the corresponding ether is CH3O C tertiary, methyl tertiary butyl ether is possible. That also we can synthesize from Williamson ether synthesis. But what about this reaction? The fourth one we cannot synthesize. Okay, fourth one we cannot synthesize. Why the fourth one we cannot synthesize, dear students? Let's listen that fourth one. Fourth option. What is the product? Ditertiary butyl ether. Ditertiary butyl ether means both the alkyl groups. This is a tertiary alkyl group. Okay, tertiary alkyl and tertiary alkyl. Both tertiary alkyls are present. It cannot be synthesized. Cannot be synthesized. Synthesized by Williamson ether synthesis. We cannot synthesize from Williamson ether synthesis. Both alkyl groups are tertiary only. So one tertiary alkyl group is present. That should be also, we have to arrange sodium alkoxides only. Either sodium alkoxide, tertiary butyl sodium alkoxide react with primary alkyl halides. So in Williamson ether synthesis, the alkyl halide must should be primary. So what type of ethers we can synthesize, dear students? In the ethers, among the two alkyl groups, one alkyl group must should be primary alkyl group, and the second alkyl group may be primary, secondary, or tertiary, or phenyl group. Whatever it may be, it is possible. Both phenyl groups are present. This also we cannot synthesize. This type of ethers also we cannot synthesize. C6H5 bond O bond C6H5 we cannot synthesize in Williamson ether synthesis because both are aryl halides. Means the halogen attached to sp2 carbon. That we cannot synthesize in Williamson ether synthesis. Both alkyl groups are tertiary. We also not possible for synthesis in Williamson ether synthesis. So the answer is fourth option. So your answer is fourth option is this type of ether we cannot synthesize it from Williamson ether synthesis. Okay, students, let's go for next question. Fourth question is very, very important. Now, anisole. For fourth one, anisole is present. How many more structures can be drawn for the same molecular formula? OCH3, anisole. This anisole is aromatic ether. It is ethers and alcohols are functional group isomers. Okay, so you can write the corresponding alcohols. Then we can arrange this OH group on benzene ring at CH3 at ortho position. Means orthomethyl phenol. The second possible structure is the OH and CH3 at meta position, metamethyl phenol and paramethyl phenol. See, this orthomethyl phenol, meta and paramethyl phenols are the positional isomers. And another important alcohol, one more alcoholic arrangement is C6H5 bond CH2 bond OH, benzyl alcohol. So like how many possible structures, the same molecular formulas. Anisole and these compounds also have same molecular formulas. From anisole we can able to write 4 types of alcohols. So the answer is second option. Second option is correct, dear students. Okay, let's see the fifth question. Which of the following ethers cannot be synthesized? See, the question is repeating models. Cannot be synthesized. Let's see the given ethers. Cannot be synthesized means here options, none of these, not all of these. All of these, fourth option. See, this is a tertiary alkyl group. The first option. This is also tertiary alkyl group. This cannot be synthesized in Williamson ether synthesis. Now it is also tertiary. One is tertiary and it is a secondary. So secondary alkyl halides, both one primary one alkyl group in Williamson ether synthesis? Ether synthesis. Okay. R bond R dash. R bond R dash. That R dash group should be, it should be primary, secondary and tertiary. It is possible, but it should be only primary. Only primary alkyl halide. Like here, tertiary and secondary is present. That's why it is also not possible. This is phenyl. Two aryl groups are phenyl groups are present. So that's why it is also not possible. So answer is all of these. These all ethers we cannot synthesize in Williamson ether synthesis. Okay, students. I hope you understood. It's a very, very important question. So in Williamson ether synthesis, ROR dash, one alkyl group should be primary. The second one alkyl group should be primary, secondary and tertiary alkyl halides. But aryl halides are not possible. Both alkyl groups are phenyl groups are not possible, and both are tertiary not possible. One tertiary, one secondary is also not possible. Okay, so the answer is fourth option, all of these, not none of these, all of these. Okay, all of these cannot be synthesized. Okay, students, let's go for fifth question. So sixth question. Which alkyl halides would be preferred for the synthesis of the following ethers by Williamson ether synthesis? See, this is the Williamson ether synthesis, C2H5 and CH3. This is isopropyl group. So it is on cleavage, the produce CH3 bond CH2 bond X plus Na plus O CH bond CH3 bond CH3. It is a primary alkyl halide. It is a secondary, means isopropyl sodium isopropoxide. Sodium isopropoxide. It is a secondary alkyl group. Already I said sodium alkoxide, that R group should be maybe primary, secondary, tertiary are possible, but alkyl halide should be primary only. So among those primary, N-propyl chloride, but here it is 2 carbons only. 2 carbons containing alkyl halide is ethyl chloride. Ethyl chloride has 2 carbons. N-propyl chloride has 3 carbons. Isopropyl chloride has a secondary. It is secondary alkyl halide. That's why it is not possible. And methyl chloride has 1 carbon. 1 carbon containing primary alkyl halide. It is 2 carbons containing primary alkyl chloride. That's why your answer is third option. So the alkyl chloride should be primary. Among that, in the Williamson ether synthesis, ethyl isopropyl ether can be synthesized among the following which alkyl halide is possible. Among these given alkyl halides, which is possible? Ethyl chloride is possible. The secondary isopropyl group should be sodium alkoxide. Okay, let's see that. The next question, seventh question, which of the following does not react with diethyl ether? Does not react with diethyl ether means C2H5 and C2H5 group. Here oxygen has lone pairs are present. When it reacts with AlCl3 or BF3, these are Lewis acids. Okay, have Lewis acids So ethyl group, the oxygen has lone pair electrons are present. It is Lewis base. They can form product either AlCl3 or BF3. This is diethyl ether group. So this AlCl3 and BF3, the reaction is possible. When reacts with HCl, it is possible. Then the cleavage of ethers, first it will be react with H plus ion. CO bond C. See both symmetrical ethers. The next one is Cl minus will be attacked, nucleophilic substitution reaction. This to decrease the positive charge on oxygen atom, this carbon and oxygen bond will be breaks and Cl minus will be attacked, and the product is C2H5OH plus C2H5Cl. But ethers cannot react with sodium alkoxides again, because ethers are Lewis bases, sodium alkoxides also bases. So base and base cannot react. So your answer is first option. Okay. Now the eighth question, C in either C bond can be cleavaged by hydrogen halides. Cleavaged by hydrogen halides. So among that hydrogen halides reactivity, HI is more reactive than HCl and then HBr and then HF. Okay, because HI is more acidic nature, it can be cleavage to give fastly H plus ion and I minus ion. Okay, so the answer is HI. Now ninth question, C. Let's see the ninth question, dear students. It is very important. Conversions. A plus B is converted into one ether. That ether is cleavaged with HI. And what is the product they are asked? Okay, students. Now let's see the ether first. CH3O bond C, CH3 methyl tertiary butyl ether. Okay, it is a primary alkyl group. Primary alkyl. It is a tertiary alkyl. So this primary alkyl group must should be alkyl halide. This must should be R-ONA, sodium alkoxide. So the correspondent A and B are A must should be you take just like a methyl chloride CH3Cl and B is Na plus O minus bond CH3 sodium tertiary butoxide. Then the corresponding ether will form. So loss of NaCl. Okay, it is SN2 mechanism. Now this ether is cleavage treated with HI. If among the given ethers one tertiary alkyl group is present, if ethers having one tertiary alkyl group present, cleavage takes place according to SN2 mechanism. Sorry, SN2 according to SN1 mechanism, and other cases follows SN2 mechanism. In other cases follows SN2 mechanism. Here HI, cleavage of methyl tertiary butyl ether with HI means follows through SN1 mechanism. In SN1 mechanism forms more stable carbocation. Here lone pairs will be takes this H plus ion. Then this bond will be breaks and forms more stable carbocation. Then I minus will be attack at more stable carbocation. The resultant product is CH3OH, methanol plus tertiary butyl iodide. CH3I, methanol plus tertiary butyl iodide. These are the X and Y. Okay, let's see among that which statements are correct. A and B. A and B. A must should be primary alkyl halide. Primary alkyl halide. Here iodides they gave. So okay, you take X and Y. It is not possible. Here A and B. Sodium methoxide and tertiary butyl bromide is not possible. X and Y, methanol and tertiary butyl iodide, it is possible. So your answer is third option. Okay, let's see that 10th question, dear students. P and Q forms anisole. Means the anisole is possible. CH3I, methyl iodide, primary alkyl halide, plus sodium phenoxide. Sodium phenoxide, it is only possible. Otherwise, the benzene ring attached to halogen, it is not possible because SN, aryl halide, does not involved in SN2 mechanism or nucleophilic substitution reactions. Now the product is O bond CH3, anisole. This anisole is treated with HI. Again, cleavage. This lone pair electrons, first it will be attract H plus ions. Then this I minus, this cleavage is takes place SN2 mechanism. This I minus will be attack primary alkyl group. Okay, because it is the positive charge. Primary alkyl groups are more favorable for SN2 mechanism. The final product is phenol plus methyl iodide. Phenol plus methyl iodide. It is very, very important, dear students. Cleavage of ethers always SN2 mechanism only. When the ethers having one tertiary alkyl group is present, then only the cleavage takes place according to SN1 mechanism. Now the products R and S are, R and S must should be phenol and methyl iodide. Phenol and methyl iodide. Okay. So the answer is D option. Let's see the D option. See, R and S must should be phenol, C6H5OH, R is C6H5OH and methyl iodide. Third option is correct. Let's see the 11th question, dear students. See this 11th question, cleavage of ethers. CH3, this is SN1 mechanism because one tertiary alkyl group is present on ethers, in ethers. It reacts with HI, means SN1 mechanism, then the cleavage takes place, here forms more positive charge and negative charge. This H plus ion will be abstract, here O, then the resultant product is iodides plus methanol. Okay, so the reaction is taking place through SN1 mechanism. So the answer is first option. Next, which of the following reagents can be distinguished by diethyl ether and isopropyl alcohol? C, isopropyl alcohol, CH3 bond CH, OH bond CH3 and diethyl ether, sorry, ethyl methyl ether, CH3 bond CH2 bond CH3. These can be distinguished by third reagent iodine and base. Iodine and base, no reaction. But it is iodoform test. Already last class only we have discussed related to iodoform test. It is a terminal secondary alcohols. Terminal secondary alcohol and ethyl alcohol gives positive haloform test. Then the product is CH3 C double bond O Na, sodium acetate. It means this it will be cleavage plus one carbon is converted into CHI3 iodoform will comes. So the answer is a third option. Okay, let's see the 13th question, dear students. Which of the following compound is produced with the reaction takes place? Means cold HI, one is phenyl group is present, the second one is benzyl group is present. Already I said this oxygen is more electronegative carbon. This benzene ring attached carbon and oxygen cannot be breaks. Okay, then here negative and here positive. Benzyl carbocation is stable carbocation. And this bond length is very less. This bond energy is low when compared to the oxygen attached to phenyl ring or oxygen attached to benzene carbon. That's why the resultant product is one is C6H5OH phenol plus the second one is benzyl alcohol. Sorry, benzyl iodide CH2I. So the answer is both one. Sorry, one is phenol, the second one is benzyl iodide. So answer is only second option. Okay, so the second option is possible. Benzyl alcohol it is not possible. Benzyl alcohol it is not possible. Okay, the possible products are phenol and benzyl iodide only. Okay, both of these 1 and 2 not possible, only 2 it is possible. Okay, let's see the 14th question, dear students. 14th question. Isopropyl group is present. Okay, this is isopropyl group and CH3 group is a tertiary alkyl group. Sorry, secondary alkyl group, it is primary alkyl group. The cleavage is with HI. So this cleavage takes place according to SN2 mechanism only. Why? When SN1 mechanism I said, dear students, when in ethers one of the alkyl group has tertiary, then only SN1. In other cases SN2 only. Then SN2 mechanism, the negative ion nucleophile mostly will be attacked at primary carbon only. Then the resultant product is CH3I plus the lone pairs will be attack on oxygen. Then the resultant CH3 bond CH bond OH. Isopropyl alcohol and methyl iodides are the major products. So the answer is first option is there. Here methyl iodide option is not there. That's why the correct answer is isopropyl alcohol or propane 2-ol and methyl iodides are the possible products. So the first option is correct. Okay. Let's see the remaining questions. Level 3. First question, listen dear students. A compound X molecular formula is C2H6O. It reacts with sodium metal. Means the X mass should be ethyl alcohol. CH3CH2OH. This is X. Reacts with sodium metal, forms sodium ethoxide. CH3 bond CH2ONA. Sodium ethoxide plus releases hydrogen gas. This X also reacts with PCl5. This X also reacting with PCl5. The product is CH3 bond CH2Cl, ethyl chloride. Okay, and produce Y and Z. If Y and Z they combined, produce the product is CH3 bond CH2 bond O bond CH2 bond CH3. Diethyl ether is the product. Okay, C2H5 bond O bond C2H5 diethyl ether means alcohol C2H6O is a alcohol react with sodium metal forms sodium ethoxide ethyl alcohol and it reacts with PC-alpha forms ethyl chloride and ethyl sodium ethoxide and ethyl chloride reaction means Williamson ether synthesis and produce diethyl ether. Okay students, very important conversion. Let's see the second question. The second one, ethene reacts with HI in the presence of AlCl3 means addition of hydrogen iodide AlCl3. The product is CH3 bond CH2I ethyl iodide is the product. Okay, when it reacts with aqueous KOH, aqueous KOH means the nucleophilic substitution reaction. The nucleophile is equal to OH minus and the resultant product is CH3 bond CH2 bond OH. Ethyl alcohol is produced. B. If the ethyl alcohol is treated with concentrated H2SO4 at lower temperature 140 degrees centigrade and produce diethyl ether C2H5O bond C2H5 plus 2 moles of ethyl alcohol react with concentrated H4 140 degrees produce diethyl ether and water. If the same, the concentrated H2SO4 reacts at 170 to 180 degrees centigrade and produce ethene. Now in the question, they are asked ethyl alcohol react with concentrated H2SO4 at 140 degrees centigrade. What is the product? The product is ethoxyethane. Ethoxyethane means ethoxyethane is nothing but diethyl ether C2H5O bond C2H5. In other case at 180 degrees ethene again the first one it will forms ethene undergoes loss of water molecule. It's very important. Okay students, let's see in the same way third question also. Ethyl chloride treated with aqueous KOH, the product is ethyl alcohol C2H5OH ethyl alcohol. Ethyl alcohol treated with concentrated stress for 140 degrees diethyl ether C2H5O bond C2H5. This is treated with Al2O3 at 360 degrees centigrade, high temperature, loss of water molecule and produce 2 moles of ethene, CH2 double bond CH2. Okay. Now the third question answer is ethene. Ethene, second option is correct. Okay. Let's see that fourth question. In the sequence of the reaction, A reacts with sodium metal and forms B reacts with ethyl iodide and followed by HI on heating. What is the product they are asked? So the A is alcohol. Okay, A is ethyl alcohol. The fourth question, A must should be ethyl alcohol, CH3CH2OH reacts with sodium metal, forms C2H5ONA, sodium ethoxide. This sodium ethoxide is treated with ethyl iodide, forms ether, diethyl ether. This treated with HI, hydrogen iodide, is a symmetrical ether upon heating and the product is C2H5I, ethyl iodide, it will forms and ethyl alcohol. Okay, 1 mole of ethyl iodide and 1 mole of ethyl alcohol is the product. So the answer is third option. Okay, let's see the fifth question is very important, dear students. CH2 double bond CH bond OCH3 upon addition of HBr at room temperature at RT. Room temperature means is the addition takes place according to Markovnikov addition rule. H plus ion is added at more hydrogens containing double bonded carbon. CH3 bond CH bond Br OCH3. If the same way treated with HBr upon heating at high temperature, then what happens will, dear students, this cleavage will take place according to SN2 mechanism. CH2 double bond CH bond OH. Enol, it is unstable and rearranges to gives acetaldehyde. And another product is methyl iodide, methyl bromide. The products, but here just room temperature only they gave, so the answer is first option, just addition of HBr, it will take place. But higher temperatures, then the cleavage will take place, CO bond cleavage will take place. The resultant products are acetaldehyde and methyl bromides. Okay, both conditions are very, very important. Okay. Okay, the remaining will continue next class. Time is over. Okay, students.